Hi, my name is Samantha Gucciardi, and today we're going to be looking at AROC and IROC. So, to give you a brief understanding of what both of these are, AROC stands for the average rate of change, or the rate of change of something at a given period in time. Now I want you to take notice in period in the definition. This will help us to determine the difference between AROC and IROC. You can also think of AROC as the old school style slope. So if you recall from grade 10, you first learned the slope formula, which is m equals y2 minus y1 over x2 minus x1. Well, it's the exact same thing here. You are calculating the slope of a secant line, and a secant line represents the distance between 2 points. So to illustrate this, if you look to your right at the top corner, the graph demonstrates the secant line between point A and point B. Next, we're looking at instantaneous rate of change, or IROC. Here you're looking at the rate of change of something at a given point in time. So to be more specific, even though it's very similar to AROC, IROC represents the rate of change at a given point in time, so at a specific point, one single point. So if you look at the graph at the bottom right corner, you are looking at the tangent line of point B. Tangent line meaning the rate or the slope of one point on a line. Now, IROC can be considered the cooler or hipper version of AROC, since it acknowledges the fact that not all functions are going to be straight lines. They are not all linear. This is what the benefit of IROC is to AROC. So an example of an AROC-IROC question is number 9 on page 304 of your Nelson Advanced Functions textbook. This question states that at a small clothing company, the estimated average cost function for producing a new line of t-shirts is C of x is equal to x squared minus 4x plus 20 all over x. This question also states that x represents t-shirts produced in thousands. It also states that C of x represents the cost of the t-shirts in dollars. Now, what x represents will come in handy to us later on when answering these questions, because it will determine what value of x we will have to plug in to our formula to get C of x. A, for example, asks you to calculate the average cost of t-shirts at a production level of 3,000 pairs. In this question, it's giving you the value of x, 3,000. However, x is not actually 3,000. X is equal to 3. We know this because the question states that x represents t-shirts in thousands. Therefore, x plugged into the equation is 3. 3,000 divided by 1,000 is equal to 3. Now, having our x value, we simply have to plug it in to our given function equation. So C of x, or in this case C of 3, is equal to 3 squared minus 4 times 3 plus 20 all over 3. It is important to remember that you must add brackets where they are needed. This will help when determining or figuring out your order of operations on your calculator to get the exact value. Once you plug it in, you will get the final answer of 5.67. This is your current value of C of x at 3,000 pairs. So for your final closing statement, you would write, therefore, the cost at 3,000 pairs is $5.67. And we know it's in dollars because it previously stated this in the question. As you may have noticed in the first part of this question, it didn't really require us to have the knowledge of a rock or I rock, since it was simply put just asking for the cost of 3,000 pairs of t-shirts produced. However, in this next part, or part B of this question, we will need to determine whether a rock or I rock are needed to answer this question. So simply put, it states, estimate the rate at which the average cost is changing at a production level of 3,000 t-shirts. So, key words to look at when answering these questions. At. At meaning at a specific point in time. Also, this question only gives you a single value of 3,000 pairs, which we know from determining in question 1, x is equal to 3. 3 represents t-shirts in thousands, right? So we all putting all these things together. So at is a key word to help us identify when IROC is used. Specific point, a single point at this point in time. So how do we calculate IROC? Well, as I said before, we're calculating by determining the slope of the tangent line. But don't you need 2 points to calculate slope? Correct, you do. However, you would need 2 points found on the tangent line. In this case, we aren't given a graph to go off of in this question. We can always make our own graph for our own purposes. However, it's easier to do it algebraically. Calculating IROC and AROC can be done both algebraically and graphically. In this case, I will be doing it algebraically. How do we do that? Well, first we'll set up our x and y coordinate table. So we know that we have x is equal to 3. Well, an easy way to pick 2 points on the found on the tangent line is by adding or subtracting 0.001 to our x coordinate, or our given x value. In this case, we'll have 2.999 and 3.001 as our x coordinates. We know that these are on our tangent line, or we're estimating that these are on our tangent line, because we are picking 2 points that are relatively close to our original x value. How do we calculate y? Well, if you recall from your other lessons or functions in grade 10, building up to grade 12, you will know that simply you will plug in your x into your equation. So after you've done that, you should come up with the values of 5.66788,963 and 5.665445185. Given these values, the reason why we have included so many of the decimal places after the decimal point is because these values are fairly similar to each other. The extended decimal place numbers kind of help us to identify or really get as much of an exact difference or rate between these two given points. So, moving on, we all know that the formula for a slope line looks like this. M is equal to y2 minus y1 over x2 minus x1. We found our x1 and our x2 values. Therefore, the next step to solving this equation is simply plugging in the numbers into our formula, our slope equation. So, here we go. We have m, which represents slope, 5.66, 5.6654, 45185, subtract 5.667, 893, all over 3.001 minus 2.9. As you can kind of tell from the start of this question and how it's set up, we are probably going to be ending up with a negative slope value. And I will just show you how this will be determined once we have our values. So plugging into your equation, you should get negative 1.22. We have a negative value. What does this mean? It does not mean we have a negative rate of change. It means that our rate of change is decreasing. So this negative value isn't included in our rate of change. It is represented to show which way our rate of change is going. So how is this line developing? Which direction is it going to? So in our final closing statement, we can say, therefore, the average cost of 3,000 pairs of t-shirts is decreasing at a rate of 1.22. And there you go. That is how you find your IROC and how you determine IROC over AROC. Thanks.